In this video, we will generate the trendline and trendline polynomials of cosine and sine using the Taylor-Maclaurin Series sum expansion. We begin with dataset of the cosine array formula, cosine of the x values 0 to 8, and the sine function, which is array formula, sine of the x values 0 to 8. And the Taylor-Maclaurin series sum, which is the summation of a times x to the power 2n plus k, where the value of k is data validation, list of items, that's 0 or 1. 0 if it is cosine, 1 if it is sine. And the value of a is negative 1 to the power of n times gamma 2n plus k plus 1. And the value of n will be from 0 to infinity. In this case, 16 is good enough. Now we continue with the coefficients of our formula. Minus 1 raised to the power n divided by the quantity, that is gamma, 2 times n plus k plus 1. Then enter. And here you have the trend line and trend line polynomial, the coefficients. We continue with the series sum, which is equal to array formula, series sum of the x values raised to the power 2n plus k, where 2n plus k starts from k, can be 0 or 1, and incremented by 2n. So 2 times 0, 0, 0, 2, 4, 6, so the increment is 2. And the coefficient, it will be this range. Then enter. And we chart this. So insert chart. And we'll use scatter chart. Use column A as label, column 1 as header. For the series, use trend line polynomial to the 8th degree, and the label, use the equation. For the legend, position at the bottom. We don't need this. We need a space, so we have to remove that. And we change, there's no yellow, we have green in the data set, so we change this to green. And for the series, point size will be maximum. All series, the point size will be maximum, except for the red one. The point size will be none. But the line thickness will be maxed. So here's our trend line and polynomial to the 8th degree. We'll calculate the polynomial regression coefficients, these coefficients, using LINEST. To do that, we complete the LINEST matrix, starting with the power, which is transpose 0 to 8. And the elements of the matrix, which is equal to array formula of the x values raised to the power 0 to 8. And now we can use LINEST. LINEST data y and data x. And LINEST data y and data x. And finally, the sine function LINEST data y and data x. So here we have the trend line and trend line polynomial. We can toggle this to 1. So this expansion approximates the sine function. So the red is on the green. If k equals 0, the expansion approximates cosine. We can do the same. We can compare the coefficients of the polynomial. That's 1, 1, 0, 1, 1, 0. This is 0, 1.16 times 10 to the minus 29. 0.0345, negative 0.0345, 1.07. And this is 0.414, 0.14, negative 0.414, negative 0.194. Here you have 0.0795, negative 0.0795, and this is 0.0433. Here you have 0.0763, negative 0.119. X to the fifth, you have negative 6.44 and 0.0474. X to the sixth, 1.57 times 10 to the minus 3. And this is 7.38 times 10 to the minus 6. So all these are negative. And to the x to the 7th, 2.72 times 10 to the minus 4. 5.14 times 10 to the minus 4. X to 8, all is negative. Negative 1.16 times 10 to the minus 5. 1.34 times 10 to the minus 5. And we can toggle this. So at k equals 1, our expansion approximates the sine function. Likewise, these values approximate the sine function polynomials. At k equals 0, it's cosine. So this approximates cosine. Likewise, the expansion also, this expansion coefficients approximates cosine. This completes the use of gamma function in the Taylor-Maclaurin series sum expansion comparing cosine and sine.